Welcome to another tutorial on MATLAB Tech. So in this particular tutorial, we will be looking into the concept related to atomic and non-atomic subsystem. So what are the things that we are going to cover in this particular video? The first one is the visual representation of atomic and non-atomic system, like how they look in MATLAB environment or MATLAB Simulink environment. Then introduction to the execution order. So in interviews, basically sometimes people ask like what is basically execution order and how it is implemented, and where you can enable the view for the execution order. So that we will see. Next we will see some settings related to atomic subsystem. Then we will go for the code generation and the difference between atomic and non-atomic code generation, and at the end we will summarize everything. So this is the content for the video. In case you want to get the details of this, so please watch till the end of the video. We will be using the same mass temper system that we have, and here we do have two types of subsystem. So this is the non-atomic subsystem, so we just converted into a subsystem, and we didn't make it atomic subsystem that you can see over here. If you just right click on the model and go for block parameters, so you will be able to see that the treat as atomic unit is not on, and because of that you are able to see like there is no thick boundary around the subsystem. But if you have a look into the atomic subsystem, so this is the atomic subsystem for the corresponding one, where you can just right click on the subsystem and go for the block parameter. Here you can see treat it as atomic subsystem is enabled, and you can see the thickness of the boundary is a little bit more compared to the previous one. So coming to the next part, right, what is basically execution order. So to enable execution order, you need to go to display, and then you need to go to blocks, and there you can click on sorted execution order. So it will enable all the execution order for the particular Simulink model. So here you are able to see the first execution block is the step block, and the second execution block is the subsystem, and the third execution block is the scope, right? And for the other subsystem that you have, that is the non-atomic subsystem. So let's go to the non-atomic subsystem. There also in the display, let's turn on the blocks and sorted execution order, so that we will be able to see the execution order for the non-atomic subsystem. So here it is 1, and you can see like the execution order is not for the subsystem, but it is related to individual blocks that are present inside the subsystem. So one by one sequentially it will execute. So first it will execute the integrator, okay, then it will execute this one, okay, and again then it will execute this block, and then it will execute this block and this block, then this block, and at the end this block. So this is the execution sequence for non-atomic subsystem, and at the end this block will be executed and all the data will be displayed, right? But if you go to the atomic subsystem, so here you do have execution order outside 0 0, so this will be the first one that will execute, and this is the second one that will execute, and this is the third one. But inside the second one, right, the 0 1, the first execution will be this one, okay, then this one, and then this one, then this one, and then this one, and then this one. So this is the execution order when you treat this subsystem as atomic subsystem. So all these will be executed in one sample time, but the order of calculation will be different. So the order of calculation will be as per the numbers that are defined, but calculation will be done within one sample time. So this is basically the confusion we get, like what is the execution order is related to. So it is not related to the sample time, like first sample time first block will execute, or second sample time second block will execute. It is not like that. Everything will be calculated at one sample time only, but the order of the calculation will be in the sequence that we are able to see. Okay, so this is the difference between the execution order for the mass damper system, atomic and non-atomic. But yeah, so there is much more difference when we jump into the atomic subsystem, and we have more control, so that we will see. Okay, so now we will jump into the code generation part. Like we will generate the code, and then we will see like what is the difference between the code for a atomic and non-atomic subsystem. Okay, so before that we need to understand some of the properties of atomic subsystem. So as you can see, this behaves as one unit. So this will be the first calculation and this will be the second calculation. Okay, so overall it is behaving as a one unit. So that is one part, and it creates separate functions when we do for code generation. Okay, so for that we need to select some options, but it usually generates the subsystem as a separate function, so that it will behave as a single unit, and in that function the calculations are done as per the execution order, like this way, right? So first, second, like this. So as per the number, the first one, then the second one, then the third one, then the fourth one, fifth one, and sixth one. Same way it will execute inside the function, but it will be present in a function. So that's why you are getting a single number for this. So mostly the atomic subsystems are usually being used when you have high amount of data transfer. So because you are using functions, right? So if you are transferring more data, then in that case you need to use the atomic subsystem. Okay, and when you are dealing with time critical applications like airbag deployment system or advanced driving assistance system, in such cases mostly you will be converting your subsystem into atomic subsystem, so that you will get quicker response. So coming to the properties of atomic subsystem. So if you just right click on the subsystem, then go for the block parameter. There in the code generation section, you will have some option. Okay, so you need to select which type of function packaging you want. Either you want auto, that let the subsystem or the Simulink decide which type of function you want it to be. Either it will be inline. Inline means it is within the main function, or it will be like a separate function. So there could be two types of function it can create. One is non-reusable and another is reusable. Okay, so reusable can be used repeatedly, so that will become a separate file and then you will be able to use it. Okay, so that part we have selected, so that we can see a separate file for this particular subsystem, which is a function. And non-reusable will be like within the same code you will have a function, and there you will be able to use the function, so it will be within the same file. Okay, so these are the four options that you have. And function name. So here function name, what we have decided is the use the subsystem name. So the subsystem name will be used. The file name option is also the subsystem name. Okay, so we will be using the file name as the subsystem name, and also the function name as the subsystem name. Okay, in this case. And when we go for the code generation, the main thing we need to take into consideration is whatever the subsystem name that we have, right? It should have no spaces. It should have only underscores or the letters that we want to give it to, so that we will not get any issue when creating a function. Because if there is spaces in the name, then in that case you will get some error while doing the code generation. Okay, so let's click on OK, and let's do the code generation. So first we will do the code generation for the other model, and then we will do the code generation for this particular model. So first we will jump into the non-atomic subsystem, and then here we will do the code generation. So let's do the code generation. So it is now doing the things on the back end, and now you will be getting the code generation report after some time. So in that you will not be able to see the mass spring damper function or file. So as you can see, we are not generating any subsystem related files over here, right? So all the models related files are there, but in that we are not having any subsystem related file, or subsystem report is empty, right? But let's jump into the other one and do generate the code, right? So we have this as the atomic subsystem, and in this we will do generate the code. So now the code generation process is going on the back end, and you will get the report, which will be quite different from the other one that we had in non-atomic subsystem. Okay, so let's see that report. And so the report will be generated very shortly, and here you can see the diagnostic window where it is trying to generate all the relevant files. Okay, and it is doing the code generation. So the HTML report is getting prepared, which is this one, and once it is ready, then you will get the report. So here you can see there is a subsystem file that we are getting. Why we are getting this? Because we have chosen the reusability option, and that's why we are getting the subsystem related files. So mass spring damper, and we have written all these things in underscore, right? So that's why you are getting everything in underscore. And when you see the code, right, then you have three major things. First is the init, then you will have maybe the loop. So let's see, this is the loop. Yeah, atomic damper. Yeah, so first you do the initialization, and then you do repeated execution. So that's why you have two functions over here. Okay, and you will have corresponding header and data. So when we compare both the reports, right, so we seen that in the atomic subsystem part that we are able to get a subsystem files, which is .c and .h file, and that way we are able to distinguish. And because of this, when you call this particular function, right, mass spring damper atomic .c, right, this file, so it will be executed as a one unit. So yeah, this is all about for atomic and non-atomic subsystem. So in summary, we covered the visual representation related to atomic and non-atomic subsystem, introduction to the execution order, and how you can enable execution orders in your models. Along with that, we also seen what is actually execution order. It is not related to the sample time, but it is related to the lines of code. Okay, and then we also seen some settings related to the atomic subsystem. Along with that, we also used those settings to generate the code. We also compared the difference between the code generated from the atomic and non-atomic subsystem. And yeah, that's all we covered in this particular tutorial. In case you are liking the channel, please consider subscribing. In case you have any comment or query, please let us know in the comment section. Also consider pressing the bell icon so that whenever any new video is coming in the channel, you will be able to get the updates on time, and that will help you to stay updated to the channel as well. So take care, have a good day.